Good morning, everyone. All right, so up to by yesterday, we have covered all of these properties about logarithm, including definition, the properties, and also common mistakes, special cases. Okay, so all of these can be written in special cases. Okay, so I would like you guys to practice on that. If during your time after class, right? Because all of these, you can substitute the B's by those special, bases in your mind. In particular, base E. Okay, you want to practice those. And we did some practice yesterday, and today we're going to continue the topics of log base 10 and log 10 and log 12. Did I leave out any properties here? I don't think so. The most important one is that the mistake people make are in this category, which I pointed out. Okay, which I'm going to point out. I'm still going to put the warning there. And a lot of people make these mistakes. Plus, okay, and some people make that mistake. Minus. Okay, these are typical mistake. Very often, very commonly seen. Oops, not that. Let me put it this way. Okay, mistake. Okay, mistake. And of course, this one is a mistake as well. And this one, these two, you see, I put the quotient rule and the change of base formula together. People can get confused with it. Okay, people get confused with it. Okay, we talked about yesterday that this and that are different. Okay, so I want to point out here. This is usually not the same as, well, as that. A lot of people make these mistakes. Not the same. Okay, not the same. All right. So that's another mistake. And today we're going to address these mistakes from another perspective. Okay. You can say these are theoretical. Yeah. The line get misplaced. Okay, mistake. Okay, so please write them down. Okay, and as we pointed out yesterday, the mistakes show up in different shape and forms. And today we're gonna still addressing the mistakes. Okay, we're gonna be doing log 10 and log 12, but we're gonna do log 12 first. I'm gonna do log 12 first. I'm gonna do log 10 later. Log 10 is about applying the change of base formula and whatever, anything else that we have learned before. Okay, so we're going to do log 10, log 12 today. Okay, so I want to show you the other perspective that these are mistakes. Do you follow me? So have your paper pencil with you. Okay, you should have all of these properties with you. Do you need to memorize them? I don't think you need memorization if you have derived it yourself. And I think a lot of students make the mistakes is because they did not do the due diligence. And they just simply memorizing it. And that's how they make those mistakes. Okay. And personally, I feel it's hard to make those mistakes if you have derived them. Do you agree with me? It's hard to make those mistakes. You cannot make those kind of mistakes if you have derived these properties yourself. So let's look at these from another perspective. Okay, so these are the examples I'm going to go over with you is by counterexample. How do we stare at those identities, so-called identities, and then recognize they're wrong? Okay, so for some people, they really don't want to derive it. Okay, in log 12, I have these. So the question was asking us to give counterexamples. Counterexamples basically is say, counterexamples basically is demonstrating that these are false. These are false. Okay, so I'm going to show you. Okay, and this one, the counterexample for that one. Give counterexamples. And that one, there are 4 of them. So we're going to do one at a time. Okay. One at a time. A different perspective. A different perspective. Okay. So all of these are false. All of these are false. Okay. How do we demonstrate that this is a false? Right. The easiest way to give counterexample. Okay. The easiest way to give counterexample. So the only difference between mine on the screen from the notes is A is X, X is B is Y. Okay, so it's just symbolically, they're just corresponding to each other. I hope that doesn't confuse you. Okay, so let's give some counterexamples. For example, if you give counterexamples, you have to choose a base. Well, you don't have to choose a base. Okay, by the way, you actually don't have to choose a base, but you can choose a base because if it's false for one base, it is false, right? If it's a false for one base, because all of these 3 statements, it's about, okay, so here's the logic. It's about for zero less than B not equals to 1. Okay, for these cases. Okay, so for any B, this is true. When you give counterexamples, that your counterexample, if you can demonstrate that for one B, and you can find X, Y, so it's a false statement, then your false one's false, right? False one's false. Mathematical statement, if true, it's always true. False one's false. So based on that logic, I will use base 2. I'll use base 2. Base 2 is much easier to handle, right? So, and I'm going to choose an X and I'm going to choose an Y. So X, I'm going to choose 2. Okay. Y, I'm going to choose a 4. Okay. And the right-hand side, B is 2, X is 2, Y is 4. Now we know how to operate them, don't we? So we just operate them. Log base 2 of 2 is equals to 1. Log base 2 of 4, that's equals to 2. So the answer is what? The answer is what? The answer is 3. So that's the right-hand side. Let's see what's on the left-hand side. The left-hand side is this guy. Under the base equals to 2. And this is what? 2 plus 4. Right? 2 plus 4. And what does that equal to? Log base 2 of 6. Okay? How do we compare 3 and log base 2 of 6? Well, 3, if you write it in logarithm on base with base 2, is log base 8. Right? 3 is the same as that. Obviously, left is not the same as right. Yes? Okay, then you can say when B is 2, X is 2, Y is 4, right? Log base 2 of these two are not the same. Right is not the same as left. Is not the same as left. Okay? Not the same. Not true once, false once. Okay, you can even elaborate it. That is under these circumstances. Okay, false once, and this is the once it is false. Okay, so you point it out directly. This is a false. Okay, 2, 4. 2, 4. Okay, is false. I want you to hear the logic, not simply the numbers I've chosen. I'm following that logic that false once, false. So I treat this as a statement. This is a statement, and this statement is false once. Okay, false once. What is that once? That once is clearly described for this base, for this X and this Y. And of course, you have numerous examples. You have many, many examples. We don't need that many. We only need one, right? So false once, and then you say, thus, now you can conclude this is false. This is false. Okay, so what I want you to hear, even though you can see I put so many steps there, but I have an idea here. I want to demonstrate, okay, throughout this process, very clearly, these steps is to demonstrate the given statement is false once. So I take great care to cover that once. So every step is clear, no, beyond the reasonable doubt, beyond any doubt, to convince you that the left is not the same as right once. And according to that logic, a mathematical statement, if false once, false. Do you guys hear that? Do you guys hear that? That's the clear logic that is in my mind. Okay, and this is the best way to show it. This is the best way to show it. So please write it down. Any other variations? Okay, shortcuts or whatever. I'll deal with it if necessary on case-by-case basis. You have, when you make a statement, when you say something, when you make a paragraph, you have to have a logic. Okay, you have to have a logic in your, you must have logic in your narrative. That's what mathematics train us to do. Okay, I know that when you write essay, you have a, sometimes you have a topic sentence at the beginning, or you have topic sentence at the end. In between, you have statements or evidence or to support your topic sentence, right? In mathematics, there's no difference. There's no difference. You clearly state your one case, the case that is false. And that's how you do it. That's how you do it. Okay. So I assume you have written down. Have you written these down? Okay. So when you have, with that example in your mind, okay, when you see that, suppose in another scenario, natural log x plus y equals to ln x plus ln y. When you are about to write this down, when you are about to write this down, think. Okay, as I pointed out, this is a very common mistake. This is a very common mistake. You should ask that, well, since I'm not sure about my memorization, is this right? You don't need to say, oh, I'm going blank. I'm going blank because I'm not sure about my memory. No, there's no need to go blank. You can analyze it. You can analyze it for yourself. You think when you are about, I'm not saying you, right? When anybody is about to write this down, think, is this right? Do I have a counterexample? Do I have a counterexample? Okay, hold on. Okay. Do I have a counterexample? Because if you do, sometimes it's much easier to find counterexample. If you have doubt. I'm not saying you always can find counterexamples, because sometimes you have doubt, you may have the right thing in front of you. Okay, so when you see this, you will think, is that right? Do I have a counterexample? And then you can, under the circumstances, right? You can say, okay, let me x equals to e, right? Y equals to e squared, right? Can I do that? Right, because now the base is set. And the right-hand side, what's the right-hand side? the right-hand side under the circumstances, this is E, and that's E squared. And what you get? What does ln E equal to? It equals to 1, right? And that equals to 2, right? So that equals to 3, isn't it? And what's on the left? On the left, you have ln E plus E squared. The question is, are they equal? Right? You can go further, right? You can go further, and what does that equal to? That equals to ln E to the power 3. So now you compare E to the power 3 and E plus E squared. Are they the same? You know what I mean? Are they the same? If these two are the same, then E to the power 3 and E plus E squared are the same. Then you'll be asking the question, are E to the power 3 the same as that? Right? Yes? In the worst case scenario, well, in the ideal case scenario, you probably have a calculator. You can quickly check by your calculator. That's not going to be the same. Okay? In the event you don't have a calculator, well, you do know that E is between 2 and 3, right? If that's the case, E squared, okay? I'm showing you some very basic skills, right? 2 squared less than 3 squared. Right? These are the operations we totally can do, right? So if E is between 2 and 3, then E squared is between 4 and 9. Yeah? So E plus E squared equals what? You just add both sides, right? 2 plus 4, that's a 6. And you add the other side, that's a 12. Well, that's a pretty, that's a pretty big range, okay? But E plus E squared is between 6 to 12. Got it? How about E to the power 3? How about E to the power 3? E is between what? 2 and 3. So E to the power 3 is between 2 to the power 3 and the 3 to the power 3. You guys follow me? These are the operations everybody should be able to do. You may not be used to it. Okay, in the worst case scenario, you don't have a calculator, but this already tells you something. They're not the same. They're not the same already. Okay, but to confirm it, okay, so E to the power 3 is between 8 and 27. This is a number between 6 and 12. And this is a number between 8 and 27. Even though they have a little overlap, by this time, you should recognize that they're not the same, right? No, not the same. No, not the same. Not the same. Now, use our logical mind. If these two are not the same, that means the right is not the same as left. The right is not the same as the left once the right is not the same as the left forever. Do you follow me? False once, false. You see, I'm still focusing on that basic logic. I'm still focusing on that basic logic. I elaborated, explained why that once, the false once case, and then, false once false. Mathematical logic is very simple. You just have to focus on that. You just have to focus on that. So this is false. So in the event that you really are drawn by your intuition, you say, oh, this is true. This seems to be true. Well, think. You don't need to go blank. You should not go blank. Not after you have taken pre-calculus. And then you say, oh, hey, let me try to find a counterexample. Okay, find counterexample. They should be at your fingertips, unless you have zero knowledge about logarithm, right? I don't think you guys are in that, in that kind of situation. You're not, right? You know some basic. We already done these graphs, right? We've done these graphs. So these are very basic operations. You just have to get the logic together. Okay, and all of these, the technique that we have shown here is needed for calculus. In particular, calculus 2 may not be exactly the same question. It's similar. How to manipulate inequality. Okay. Calculus 2, chapter 11. Calculus 2, chapter 11. I may be wrong by the chapters. It's in the chapter of series sequence and that chapter. You need to know how to manipulate inequalities. And that's a big chapter in calculus 2. You can easily lose 20, 30 points. Okay, don't think of these little techniques, do it. Do it. You do it a couple of times, it's yours. If just watch, it's not yours. Okay, so don't make these kind of mistakes. So that's the reason I went through this logic and show it to you, and you can, you can get similar examples. Okay, so I'm going to leave this second one for your practice in class. Okay, so I want you to practice on getting a counterexample for this case. Okay, do you guys have any questions? No, so now it's your turn. Okay, so please find a counterexample. Counterexample means what? You specify the B, and you specify the X, you specify the Y. And just remember, X has to be larger than 0, Y has to be larger than 0. So we operate in the domain. This process allows us to practice with log 2, log 3, log 5, log 6, and so on and so forth, okay? So we are practicing those examples that were given in those exercises. Okay. We good? I'm gonna give you a couple minutes. Okay, just be patient with yourself. You can totally do what I did. Logically, okay? The key word is logic. The key word is logic.
With me? Yeah.
Sorry? Does someone have a question? Okay, so do you have a count? Could someone contribute a counterexample here? You need to specify the B. You need to specify the X. I mean, you need to specify the Y. You also have to guarantee X minus Y is larger than 0. Okay, otherwise it's going to be falling out of the domain. Okay, so that's the other thing you need to be careful about. You need to guarantee this is larger than 0 as well.
Mama Basics, thank you for the 100.
So today's video is.
He wants to go for.
Did I hear something?
Which is now doing over 150 miles per hour. This car's maximum speed, but he's still not catching the other car. But I've got the foot to the floor, get as fast as I can possibly go and not catch them. It starts to get a real concern. Back in for the day shift.
Okay. So what examples have you come up with? There are many, many examples. Okay, you just have to come up with yours. Now I will take the answer. Yeah, I turn him off. Thank you, Mikhail. Okay, B. What B have you chosen? Anybody? Come on, you can type your choose 2, 3, 2. 2, 3, 2. Is that what you chosen? Yeah. Okay, so what's your operation? So left, right, right, left. You plug in the left. So that's a 2. And that's a 3 minus 2. And that's equals to log base 2 of 1, right? And that's equals to 0. And right, the right-hand side, okay, base is 2. And that's a 3. And that's a 2. Okay. And then what? This is going to be 1. Okay. Or you subtract these two, this is not going to be 0. You don't even have to go this far. You just say this is not 0. Right? You don't need to bother with a calculator because it's obvious, right? Log base 2, log base 3. If you want to go further, you can do the quotient rule. You can do the quotient rule, right? You can do the quotient rule. Log base 2 and 3 over 2. That's not 0, right? Thus, then you say thus. In this case, these two are not the same. In this case, it's not the same, right? False ones, false. So this whole thing is false. This is the false ones we just described. False ones, false. For that particular base, for that particular X, that particular Y is false. In that case, it's false. False once false. This entire statement is false. Very good job. Very good job, Bailey. Okay, very good job. Now, let's look at the next ones, the next two. The next two, if you look at the number 3 and number 4, number 4 is actually the special case of this guy. So if this is false, this is false. Do you follow me? So you don't need to give a separate example, but you certainly can. You can use base 2, base E, whatever. But if you can demonstrate this is false, okay, so let me write it down. If we could demonstrate this is false, because this letter case is a special case of that, is when base is 10, right? Then, oops. Then this guy is false. Is false. So you can actually use one counterexample to kill two. Okay, so that's so let's work on counterexample for that one. This counterexample, which is base, for base 10, right? Common log. You don't have to choose the base now because the base is already chosen. That's 10, right? You just have to choose X, Y. Okay, so do you guys want to contribute, or you want me to go straight ahead? Do you want to try? Do you want to try? Okay, I'm going to give you a couple of minutes to try. Go try it. You just have to supply the number for X, Y. Make sure they're easy to operate, because you just want to make a point. You just want to make a point. It's not true. So whenever you are about to write this down, you think of that counterexample. That's what we're doing here. Okay, so we point these mistakes in different perspectives so that you will never, ever make those mistakes. Okay, we will never, ever make those mistakes. When you're ready, you can put your answer on the chat. Or if you want to show your work, you can pronto or upload your picture to chat. You know, all learning involves making mistakes, including mathematics in particular. Okay, so do not be afraid of making mistakes. And I just never want you guys to be in a situation that I go blank. Go blank is not a good situation. Okay, because that means you're not going to get any point, right? You want to be able to utilize whatever you still know to figure out something and do the steps with reasons. All right, anybody would like to contribute a counterexample? Well, take your time. I'm going to step out just for a minute. I'll be right back. All right. Okay, Cortland says, I think I have one. Oh, right. What is it? Okay, so x equals to 10. Y is what? 2. Okay. And the left-hand side, ten divided by 2. You see, at the heart of this question, this mistake is the order of operation. Okay, at the heart of this. And the right-hand side is log 10, and this is log 2. Okay, in the left-hand side case, you have to do the quotient first, and then apply the logarithm. On the right-hand side, you have to do the 2 logarithm first separately, and then apply the property, and then you do that. Okay, so of course here you're gonna have log base, log 5. But you still have to make the case. You need to use a calculator to make that case that this is not the same as that. Your example would work, you know, provided you have the calculator. Okay, so you do log 10. Log 10 equals to 1, by the way, isn't it? So you just have to do log 2. Common log 2, and then you plug in, you get a numerical value. And this final numerical value, and over here, you plug in your calculator, you get, they're different, right? They're different. That's one way to do it. That's one way to do it. Do you want me to supply you one, which doesn't really need a calculator?
Yeah, that was my next question. I was going to ask if there were some simpler numbers I could have used.
Think of 10 to power.
Okay.
Power 10. From the examples I gave you earlier, okay, from these examples, from these examples, did you notice that I've chosen the number that is the power of the base? Did you notice that? Did you notice that I choose the power, we have choose the xy to be the power of the base? Did you notice that? If you notice that, and I mean, it's not necessary you have to do it that way, but in this particular case, because you just have to fish out one example, okay? So I would have chosen x equals to 1,000, right? I can choose y equals to 100. You know what I mean? And left-hand side would be, so these operations will be so much easier to handle, isn't it? So 1,000 divided by 100, and that's log 10. Log 10 is 1. Okay, so think of the properties we have learned, right? And over here, you're gonna have 1,000, and here you have 100, and you do this separately. So this is 3 and this is 2. So obviously 1 is not the same as 3/2, right? So in this case, right, and you're gonna point out, you know, sometime to make your point, you want to point out the most obvious. You want to point out the most obvious. I have already demonstrated they're not the same. Now I want to point it out. Point it out the easiest to make your point. Point out the easiest to make our point. Okay, and thus, false ones, false. So we're still following that logic, false ones, false. We carefully take care of the one case, that false ones case, to make sure there's no flaw in the process. There's no flaw in the process. And then you make your case. You make your case because you only need one case carefully demonstrated, clearly calculated, precisely, operate it as much as possible to make your case. All right, so that's log 12. Okay, so we covered all the cases. I don't think those 4 mistakes is limited. The mistakes in logarithm is not limited to those other cases. And you may want to, let's go back here again, that this is false, right? And this false, as we demonstrated yesterday, for different bases, it show up in different forms. You show up in different forms. So you want to be able to recognize those are mistakes. Those are mistakes, okay? Now let's go back to log 10. Log 10. Log 10 is about change your base formula. But by the time we get to log 10, we have learned a lot of other properties. So feel free to use them, right? So I'm going to bring up the change your base formula. Okay, and in fact, I'm going to bring all of these properties with me. How about that? Let me do this. Let me bring the log 10 up. Log 10. Okay, we have all of these in the boxes, the correct ones, and the mistakes are pointed out. Okay, so log 10, let's practice. Okay, let me give you some cases. For example, the first one. Okay, we start from something easy. Log base A, provided this A satisfies the requirement of base, which is greater than 0, not equals to 1. Right, what would that be? Log base A raised to the power half. And the answer is, what's the answer? Half, right? Okay. Let's try number 2. How about you try number 2? It's log 1 over square root of 1,000. You have more than one way to do it. Okay, you have more than one way to do it. Oh, sorry, I made a mistake here. This should be an A. How about I pick a couple questions for you? Okay, so I'm going to pick a couple questions for you. Number 4. Number 6. Number 8. Number 9. First round. Okay, this is practicing our skills. Okay, practicing our skills. Now you have all the tools. We have all the tools here. Okay. I trust you have them, you know, you have them with you. The fundamental is a definition. The fundamental is a definition. The most basic is definition. If whenever you get stuck with logarithm questions, whenever you get stuck, okay, so here's my advice. Okay, you may get stuck here and there once in a while when you deal with logarithm. Whenever you get stuck, think of a definition. Think of a definition. You may get some ideas as how to deal with that. Or you find a way. You will find a way. If you want to show your work, as always, much appreciated. I have given you 3 quizzes by this time, okay? And I hope you guys are not too anxious by it. Okay, but I just want you guys to practice. Okay, I have enough. I think I give you enough time. If there's any issues, please let me know. And will I give you more quizzes? I don't think so. Not this week. I think 3 quizzes is more than enough. Okay, but do get on them earlier. The goal is for you to practice. Not only just to handle the quizzes, you really need to practice the things, the exercises in the notes. So I selected some questions from the notes and make up those quizzes. And the quiz questions, some of those are very typical questions I saw and typical mistakes I saw when I was teaching Cal. You done with number 2? Good. What you get? Log the root 10 over 100. Do you mind to show your work to us, Mikkel? The final result should not have log. Okay. Bailey got negative 1.5. All right. Do you want to show your work, Bailey? Mikkel, feel free to send your work in. Okay, if you don't want to share, that's fine. Okay, so I'm gonna show you my work, but first I'd like to acknowledge that you got the right answer, Bailey. Okay, let's see who shared the work. Thank you. We got a pronto message. Oh, Mikkel doesn't have a pronto. Could you download pronto, Mikkel? Because that's a one source of communication I have with you guys. It would be nice if you download that. You know what I mean? It's a free app. Okay, so now I see this pronto sent to me. So I'm downloading it. And I'm going to share with you. I'm going to share with you. Thank you for sharing. Thank you for sharing. So let me turn it, turn it, turn it. Do you see that? Do you guys see that? I will put some annotations as I go, as I'm checking the work. You may like to put equal sign there. Okay, so what's being done here is that log 1 over square root of 1000, and he turned that square root of 1000 with a power -1. And that's good. And 1000, root 1000 to the power half, that take care of the root part. And then we multiply, he multiplied the half with -1, that's -half. And then he bring the power -half out, log 1000 is 3. So that's how he get 3 times -half. And I think the way you write it, you may like to put a parentheses here and then equal sign. I think it's very good work. Okay, it's very good work. So I'm going to rewrite his work. Okay, and I'm going to also give you some different versions of some other ways of doing it. Thank you for sharing this. Okay, so let's go back here. Okay, so I'm going to reproduce your work, Bailey. Okay, thank you very much. You did a very good job. And I'm going to reproduce his work so everybody could see clearly. So what he did is that this is 1/, right? So what he used that 1/b is b raised to the power -1. Okay, so the b, of course, is the square root of 1000. So he put that in, and he put the parentheses in there and the -1. Okay, correct me if I misinterpreted your work, Bailey. Thank you. So the next step he did is that he put in the half. Okay, so he operated inside the parentheses and the square root, and he made that to be the power of half. Okay, so what he used here is the square root of something, omega, is omega to the power of half. Okay, so that's what he used. So I'm just putting some notes for your convenience. You don't need to. When you show your work, okay. The next step he did, he has log, multiply the exponents. So it's 1000 raised to the power of -half. And what he used here is b to the power of m raised and to the power n equals to b raised to the power of m times n, right? That's the property he used. And the next step, he used the power rule. He bring the 1/2 and then log 1000. And what property did he use here? What property did he use here? He used the power property. Base B, capital A, and I use the symbol heart. Okay, the power of heart equals to heart multiply this guy. That's the property he used, right? And finally, he got a -half, and log 1000 is a 3. Okay, because 1000 is 10 to the power 3. So in the end, he got a -3/2, which is -1.5. Got it? Very good job. Very good job. And I also wish to tell you is it's not the only way to do it. This is not the only way to do it at all. Okay, so I want to inspire you guys to, you know, pursue other ways to do it. Maybe you'll find another way to do it. I'm sure you will because they are there. They're there. Okay, so let me show you a couple ways that I can think of on top of my head. Okay, for example, right? I can take this one. I can use a quotient rule, can I? Can I use a quotient rule? Yeah, I can use a quotient rule. If I use a quotient rule, and of course this is 0, right? And I can bring out the half. That's log 1000, right? Right? That you can write that as 1000 to the power half, right? Like Bailey did. You can write this one to replace that guy, right? Then you also get negative half. Whoops. Negative half times 3. You get the same answer. You get the same answer. Okay, but once you write it that way, you don't need to write the decimal. Just a fraction is good enough. Okay, there are other ways to do it. Yes, there are many other ways you can do it along that line. Okay. All right. So let's look at number 4. I believe some of you have done number 4, right? Log base 8, 0.25. Without calculator, okay? So you can, on this set, we ask you to do them without using calculator. What you do? If I were you, I would transform this to a fraction. Okay, that's a quarter. That's a quarter. Okay. Not the only way to do it. I'm going to apply the quotient rule. On log base 8 of 1, that's a 0. Minus log base 2, 4. What are we going to do about that? There are ways to handle this. But what I'm going to show you, we can use change of base formula. We can use change of base. Okay, so what is a change of base formula? Do you guys have change of base formula with you? Okay, so I'm going to bring it up. This is not the only way to do it. Okay, you can do it without using change of base. But changing base is that now we have the old base. The old base is 8. Omega is 4. So our old base is 8. Omega is 4. What new base do we want to change to? Anyone. You can change to any new base. But I'm going to change to new base 2. Why do I want to change it to new base 2? because 8 is a power of 2, 4 is a power of 2. So my omega is a 4, and my old base was an 8. So I'm using my change of base formula. So here I go. I got this guy. You follow me? You guys follow me? I'm still change. I put change. I'm going to put the change of base formula right here. So make sure everybody follows. Does everybody follow? The old base was 8. Omega is 4. I want to change to a new base. New base is chosen of the chosen new base is 2. Do I have to choose 2? Of course not. You can choose any base you want, your choice. Okay, and they will all work out. They will all work out. You follow me? Okay, so suppose I chose base 2. Okay, we're gonna try to see what if we choose a different base. Okay, so there's still a negative sign follows it. Log base 2 of 4, that's equals to 2, and log base 2 of 8, that's equals to 3. We're done. Then you might say, hey, I don't want to choose new base 2. I want to choose new base 10. Could I do that? Yes, absolutely. Okay, so I'm going to show you. Are you guys ready? So write down what we done first, the first way of doing it. Okay. You got it? Okay, so here I'm going to put a little note here. Use change of base. Change of base. We use the new base 2. We use the new base 2. Okay. So suppose we don't use new base 2. Suppose we don't use new base 2. What new base you want to use? What new base would you like to use? How about common log? Or natural log? How about natural log? Our old base was 8. Omega is 4. Do you guys follow me? You need to write it down, okay? The new base of my choice, I'm going to use E. Every opportunity I get, I want to try to get you guys to use E. And of course, log base E is ln. Log base E is ln. Omega was 4. And the old base was 8. Yes? So here we're going to use, we're still going to use change of base, but now we use this guy. Okay? So the next step, we have negative of ln 4 over ln 8. Natural log 4, natural log 8. What are we going to do about it? Here's what you can do about it. Right? Negative sign still there. ln 4 over ln 8. ln 4 is ln 2 squared. ln 8 is ln 2 to the power of 3. Using power rule, Okay, what is the power rule? Do we still remember the power rule? We have proved it, right? What is the power rule? Log base B capital A raised to the power of heart is equals to, yeah, equals to the heart multiply log base B of A. Okay, this is called power property. So how does that apply to ln 2 squared? Natural log 2 squared. You just bring the heart here, right? The base is E. So it's going to be 2 times ln 2. Yeah? How do you apply the same power rule to ln 2 to the power 3? You're going to get 3 to the multiply ln 2, yeah? So you're going to put a 2 to the, so this piece equals to 2 times ln 2. The bottom is 3 times ln 2. What happens? What happened next? Equals to ln 2 is a number. ln 2 is a number. ln 2 and ln 2 are reduced. So you're going to get negative 2 over 3. Do you follow me? Do you want to try this by yourself? Use or change your base formula. Okay, I'm gonna turn off the share. Okay, I'm gonna turn off the screen. How about you guys try this? Okay, you really need to do it yourself to get familiar with change your base formula. Watching the screen is not enough. So what I'm gonna do is I'm gonna stop the share. Oh, we don't have much time left. Okay, so I'm gonna give you 4 minutes. I'm gonna give you 4 minutes. Okay. Tomorrow we will continue to share to practice these, okay? And you need to practice. You need practice. Do you hear me? You need practice. So I'm going to give you 4 minutes to practice whatever we have done so far. Number 2, number 4. Okay, we'll continue this tomorrow. So I'm going to stop the share. Don't look at the screen. Just get a piece of paper. Just do it. Just do it. If you get stuck, no big deal. No big deal because the answers are right there, right? I will share with you again. So I'm going to stop the share. Do it. Well, you may come up with a new way to do it, by the way. Okay, there's another way to do it though. After we come back, there is another way to do it without having to use change of base. Okay. you can see that you totally can do it, right? You totally can do it. Have confidence. You are able to do it. You are able to do it, okay? The only reason that you think you're not sure is because you haven't put your hands on it. Once you put your hands on it, see, you can do it. You can totally do it, right? So without further ado, and as I promised, and I said there's a way not to have to, there's a way you don't have to use all of these just simply by doing definition, okay? I mentioned earlier that all the logarithm questions, they can all be traced back to definition. Okay, they can all trace back to definition. So here I'm going to show you how some basic manipulation will get this done. Okay, you don't need to remember the fancy, change your base formula. Okay, if that's a scenario, you're not going to be able to. You forget. You totally go blank on the change your base formula, right? That's okay. Even in that case, you can get this done. Okay, so I'm going to show you how that can be done. Okay, we basically going to try to see how I can write 4. Okay, how I can write 1/4, right? Because you want to know this answer. We want to find out this answer. Over here, triangle. Okay, so I'm going to use definition. I'm going to use definition. What does definition say? Okay, so allow me to copy the definition so that way we can go a little faster. Okay, we're working on this, time constraint. We have 3 minutes left. So in the definition, in the basic definition, here we have 8. So this is 8, right? Omega is 1/4. Omega is 1/4. Okay, omega is 1/4. So this is 1/4. And we just have to figure out what a triangle is, right? You guys follow me? So we just have to figure out the triangle is. So by using the definition, assume this is a triangle, or you can use X if you want to. A lot of people like to use X, no problem. And then this logarithm question is transformed to this question. Yeah, you guys see that? And on this question, okay, you can write 8 at the base 2 to the power 3. 2 to the power 3 is 8. 4 is 2 to the power of what? -2. These are very basic, exponents operation, isn't it? And then what you get? You get 2 raised to the power of 3 times of that triangle. And that equals to 2 times of -2. They have the same base of exponential form, and then 3 times the triangle should equals to -2. You know what I mean? So you turn that question into an equation. You turn that question to an equation. So in the end, you get triangle equals to -2/3. Okay, and then you can go back to your question and you tell the reader, and this equals to what? -2/3. You see, you can figure it out in so many different ways. So many different ways. As a matter of fact, you cannot exhaust the number of ways to do this kind of question. Okay, so I'm going to close today for today's lecture. And of course, we haven't done 6, 8, 9. But I want you guys to practice the entire log 10 as today's homework. I think I have given you the homework as log 10, did I? Okay, so keep on practicing. Tomorrow is Thursday. We have 2 hours and we're gonna practice. Okay, so I want you guys to be ready to be involved, to get your paper, pencil. Okay, just keep on practicing. Okay, so I will see you guys tomorrow. Have a great day.
Thank you.
Thank you.